Let's take a look at direct and inverse variation. As a reminder, in direct variation, if x increases, then y also increases. Also, if x is decreasing, then y is decreasing. The equation that you need to remember for direct variation is y equals k times x. If you solve for k, you get that you can find the constant of variation, or the constant of proportionality, by using the equation k equals y divided by x. Remember that if you see addition or subtraction in an equation, it is not direct variation. If you're looking at a graph for direct variation, it's important to remember that it is a straight line that goes through the origin, which is 0, 0. So all four of these graphs are straight lines that go through 0, 0. So they all represent direct variation. For inverse variation, if x is increasing, then y is decreasing. Or if x is decreasing, then y is increasing. They are going in opposite directions. The equation for inverse variation is y equals k divided by x. To find the constant of variation, the constant of proportionality, if you solve this equation for k, you get k equals x times y. Again, if you have addition or subtraction, it is not inverse variation. Let's take a look at a few examples. First, we know that point A is an element of a direct variation. You want to plot 2 points other than point A that are elements of this direct variation. Well, we said earlier that for direct variation, your graph is a straight line that goes through 0, 0. So we know that 0, 0 must be one of our points. To find another point, we need to look at the slope because we know that this is a straight line. So if I count my slope, I'm going up 1, 2, 3, 4, and over 1. So I'm going to go up 1, 2, 3, 4 again, and over 1. This point here is also a part of our direct variation. There are other points that are also a part of this direct variation. You would just keep counting out the slope, up 4 over 1, up 4 over 1, to get other points, but it only asks us to plot 2, so we can be done. For problem number 2, it says, which graph represents direct variation? Since we are looking for direct variation, remember that we have to have a straight line that goes through 0, 0. Well, all 4 of these graphs are straight lines. And it might be a little bit hard to see, but if we look at where 0, 0 is, here's 0, 0, here's 0, 0, here's 0, 0, and here's 0, 0. C is the only graph where the line goes through 0, 0. So C is our direct variation. Here, our problem says, which equation best represents the direct variation shown in the graph? The easiest thing to do here is to just graph each of these answer choices. But we have W and H, we don't have X and Y. If we look here, this is the x-axis along the bottom, and that's hours. So we're going to make H be X, and W is going to be Y. So I'm just going to go ahead and change those in our equations. So we have y equals, and I'm going to change all of my h's to x's. Now I'm just going to go to Desmos and type all of these equations in. So let's look at these graphs in Desmos. I'm going to zoom out a little bit. So our graph is definitely a straight line, and it goes through 0, 0. And we know that because we are told it is direct variation. So the purple one is definitely not a straight line. So I'm going to go ahead and get rid of that one. The black one does not go through 0, 0. So I'm going to get rid of that one. Now I need to decide if the green line or the red line matches my graph. To figure this out, the best thing to do is to pick a point along the line. I'm going to pick 2, 20, and then see which line goes through that point 2, 20. Since I zoomed out, it might be a little bit hard to tell. So if you get stuck, you can just type in 2, 20. And you can see that that point is on the red line. So y equals 10x, or w equals 10h, is the best equation. Problem number 4 says, it took Martha 120 minutes to make 15 hand-painted posters for the club by herself. How many people, all working at the same rate as Martha, would it have taken to get the same job done in 40 minutes? This problem does not say if it is direct or inverse, so we need to think about it. We are talking about people making posters and how fast they can do that. If you have more people making posters, is it going to take more time or less time? It should take less time. So that means the more people are working, the less time it takes. So as the number of people increases, the amount of time decreases. So this is going to be inverse variation. Now, our equation for inverse variation is y equals k divided by x. I'm going to make y the amount of time and x the number of people. So, I know that Martha took 120 minutes to make the posters by herself. So, it took 120 minutes when there was only one person working. K divided by 1 is just k. So this tells us that k is going to be 120. So my new equation is y equals 120 divided by x. Now I want to know how many people, all working at the same rate as Martha, would it have taken to do the same job in 40 minutes. So I know that my time, or my y, is 40, and I want to know how many people. Now I need to solve for x. The easiest way to do this is to type y equals one side of the equation into Desmos, and then y equals the other side of the equation into Desmos. Then I want to look for where the graphs intersect. So if I zoom out a little bit, They intersect at the point 3, 40. We want to solve for x. So the x is the first number, so we get x equals 3. This means that there would be 3 people working if they finished the job in 40 minutes. Our last example says, write which table represents direct variation and which table represents inverse variation. To figure this out, you need to pay attention to what k is. For direct variation, you find k by doing y divided by x. For inverse variation, you find k by doing x times y. So, I'm going to write direct on the left side of the table, and I'm going to find what k would be. So I'm going to do y divided by x. So y divided by x, negative 6 divided by negative 10, you can type that in your calculator. It's 3/5. Negative 20 divided by negative 3, 20 divided by 3, 30 divided by 2 is 15, 12 divided by 5 is 12/5. Those are not the same number, which means the first table is not direct. Let's try the other ones. 8 divided by 120 is 1 over 15. 6 divided by 90 is 1 over 15. 4 divided by 60 is 1 over 15. And 3 divided by 45 is 1 over 15. So this one is direct. Let's try the third one. 4 divided by 8 is 1/2. 5 divided by 10 is 1/2. 24 divided by 12 is 2. And 6 divided by 18 is 1/3. So that one is not direct because those are not the same number. And if we look at the last table, 3 divided by 1 is 3. 4.5 divided by 1.5 is 3. 21 divided by 7 is 3. And 28.5 divided by 9.5 is 3. So this one is direct. Let's check and see if they are inverse. On the right side, I'm going to write the k for inverse. And to do that, I need to do x times y. Negative 10 times negative 6 is 60. Negative 3 times negative 20 is 60. 2 times 30 is 60. 5 times 12 is 60. So this one is inverse. I don't need to check the second one because you can never have an equation that is both direct and inverse variation. So let's check the third one. X times y. So 8 times 4 is 32. 10 times 5 is 50. 12 times 24 is 288. And 18 times 6 is 108, which means that one is not inverse either because I got different numbers. So this one is neither.